A very, very good evening to all my lovely students. How are you? Sri Devi says good evening. Good evening, Sri Devi. Pragna, Srinivasulu Reddy, Jastu Yadav. Hello, good evening. Pinky, Rani Reddy, good evening. Hello, Ganesh. How are you all doing? Chalam D. Quickly like the video and then we are going to start this session. Arifa, good evening. Anil Tala, good evening everybody. How are you? Please tell me how are you in the comment box quickly. How are you doing? Namaste, Srinidhi, good evening. Manoj, Ritika, Prince. Had your lunch? Reshma, good evening. Yes. Okay, everyone. Very, very good evening. Okay. All right. So, just 5 more days and NEET exam is there. It's very important week for all of you and us as well. Echo is coming. Voice is fine. Fine. Okay. Yes, I have had my lunch. I am also doing very, very good. Did you all understand the Lewis dot structures yesterday? How we have drawn the Lewis dot structure by TVSU method, all of you? Did you all understand that TVSU method? Is the TVSU method clear to everybody? We'll practice 1 or 2 more problems from TVSU method and then we are going to do drawbacks of Lewis dot structure and we'll see slowly how other ways are there to make the structure. If anybody is not clear with the TVSU, it's okay, not a problem. Okay. Whenever you feel like drawing a structure, don't use TVSU. That is just one of the method that is there. Other methods are much better than this. Okay, other methods will give you a clear-cut structure, like what is the exact shape of the molecule, where the bonds are actually. Okay, so other, someone says voice is not clear. Is the voice clear? Sudhir? Many people are saying voice are not clear. Clear only? Okay. So we'll be starting with our Lewis dot structure once again, 1 or 2 practice questions, and then we are going to go towards the drawbacks of Lewis dot structures. Okay. All right, everybody. Yesterday I have told you these things, that to draw Lewis dot structure, we'll need TVSU. T was total electron required to complete the octets. T was nothing but 8 times number of atoms. If atom is hydrogen, then 2 times number of hydrogen. Can you play the video and check? T was nothing but 8 times number of atoms. If atom is not clear. 1 second, guys. Now the voice seems to be better. Is it better now? Now I think it is better. Now is it better? Please do not talk among yourselves, everybody. Okay, all right, guys. So T was total electrons, 8 times number of atoms we were doing, and for hydrogens we were multiplying by 2. V was valence electron, which was nothing but sum of valence electrons plus minus charge. So if charge is negative, minus minus automatically, that means electrons will add up. And if there is a positive charge, then electrons you will subtract from there. Shared electrons was T minus V, was shared electrons. We will keep those shared electrons in between the two atoms. And U was unshared electrons, which was V minus S. Unshared electrons will be kept on the face or on the top of atoms which are not in sharing. Okay. So these were the examples we have drawn in the last class. CO2, CH4, ammonia, carbonate, nitrate, ozone. These were the homeworks I gave you. These were the homeworks I have given you. Let us draw 2 of them and then we are going to go for the drawbacks. Okay. Let me draw 2 more of them. Let's say phosphate, PO4 3 minus, PO4 3 minus, and let's do SO3. PO4 3 minus, SO3, and one positive one also I'll do, NO2 positive. Okay, these 3 I'm going to draw, or SO2 let's do, SO2. Okay, SO2, PO4 3 minus, and NO2 plus. All of you can see and draw with me. Phosphate, SO3, and NO2 positive. These are the 3 more we will be drawing. Okay, phosphate, TVSU, quickly, TVSU, total, all 5 people say we want octet, so 5 into 8, 40. Valence electron, phosphorus belongs to nitrogen family, so 5 valence electrons. Oxygen belongs to 16th group, so 6 valence electrons, 4 oxygens are there, 6 4s are 24, plus extra 3 electrons due to negative charge. Okay, so 5 plus 3, 8, 8 plus 24, 32. Shared electrons will be 40 minus 32. 8 shared electrons, and unshared electrons are going to come out to be, unshared electrons are going to be V minus S, 32 minus 8, which comes out to be 24 unshared electrons. So TVSU is clear to us. Okay, TVSU is clear to us. You can remove the chats. Yeah. So we get phosphorus in the middle, 4 oxygens at the sides. First, let us give the shared electrons. So shared electrons are 8. 1, 2, 3, 4, 5, 6, 7, 8. Phosphorus ka octet is complete. Phosphorus ka octet is complete, so we don't have to give any more electrons to phosphorus. Phosphorus says, I am happy. My octet is complete. Then unshared electrons will be given only to oxygen. 24 are there, no? So we'll start giving 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Once we have given all the 24, then this oxygen is complete octet. This oxygen has complete octet. This oxygen has complete octet. And this oxygen also has complete octet. Very good. So this is the structure. Is the structure correct? See, it was correct according to Lewis dot theory. He thought that the structure is correct. In today's standard, this is not the correct structure of phosphate. So what did Lewis think? Lewis think the formula will be, or the structure will be, P single bond O, single bond O, single bond O, single bond O. Whenever oxygen is single bond, oxygen says, give me a negative charge. Okay. How many negative charges we have? 3 I have. So 3 of the oxygen, so I can satisfy with a minus charge. 3 of the oxygen, so I can satisfy with a minus charge. Then other oxygen has to be given a coordinate bond. This is the Lewis dot structure of phosphate. Although from today's standard, okay, Lewis theory was a very old theory. This theory came in late 18,000 century. So right now this 1800 century. Right now this theory is very old. So this is not a correct structure. Okay, we will correct it in the next. In today's class only we are going to correct it. Okay, so this is not a correct structure, but according to Lewis this was the structure. Not a correct structure. Remember it. So you will see in the drawback, till the time the central atom belongs to second period, which is carbon, nitrogen, oxygen, fluorine, boron, okay, till the time the central atom belongs to second period, in that case octet rule has to be followed. But when we go to higher people, higher members like phosphorus, chlorine, sulfur, bromine, iodine, then the Lewis octet rule will fail. So there will be drawbacks of this. Okay, this is the structure according to Lewis, not the real structure. Okay, for SO3 also you will not get the correct structure. Central atom is, you can see here, it's a period 3 member. Okay, so here also the structure that we will get from Lewis theory will not be a correct structure. Okay, let us see. SO3, TVSU, total. All 4 people in the, all 4 atoms require octet. So 4 8s are 32. Valence electron. Sulfur has 6 valence electron because it is from oxygen family. Oxygen also has 6. So 6 times 3. So we get 24 valence electrons. 24 valence electrons. Shared electrons 32 minus 24, which is going to be 8. So 8 sharing. And unshared electrons 24 minus 8, that is going to be 16 unshared electrons. 8 and 16. 8 sharing, 16 unshared. So how do we draw? We'll draw like this. Sulfur in the middle, oxygens on the side. 8 sharing. 8 sharing. Okay, let us give. You take 1, 2, you take 3, 4, you take 5, 6. 2 more I have to give, any one place you give. Let me give it here. You take more. Sulfur says, my octet is done, I don't need any more electrons. So S double bond O, S single bond O, S single bond O. Sulfur ka octet is already complete. So unshared electrons will be given only to oxygen. 16 are there, 1, 2, 3, 4, 5, 6, 7, 8, this oxygen is done, 9, 10, 11, 12, 13, 14, 15, 16. This oxygen is happy with the complete octet. This oxygen is happy with the complete octet. This oxygen is also happy with the complete octet. Okay, so the structure becomes like this. S double bond O, single bond O, single bond O. S double bond O, single bond O, single bond O. Oxygen is singly bonded, says give me a negative charge. We saw, array, there is no negative charge. I can't give you negative charge. So you take coordinate bond. You take a coordinate bond. You also take a coordinate bond. Again telling you, this is going to be a wrong structure. Okay, you can circle it and say, not a correct structure. So Lewis structures are not correct structure. So these are the structures which are formed by following the octet rule. But from today's standard, actually there is no octet rule. People do not have to follow the octet rule to be stable. It is found that in today's time, when we look at the structures of the molecules, most of the molecules do not follow octet rule. Only few are there which have to keep 8 electrons. There is no such compulsion to keep 8 electrons. Okay, so Lewis thought that by becoming like a noble gas, by becoming like an inert gas configuration, they will be stable. But from today's standard, that is not a concept. Otherwise, xenon would have never combined Okay, xenon is a noble gas. Xenon is already stable, but xenon to makes compounds. XeF6, XeF4, XeF2, XeO3, XeO4. So today's standard octet rule is a scam. Okay, octet rule does not exist. Okay, we'll see the drawback. So these are not correct structures. The structures that you drew yesterday are correct structure. Okay, these structures are correct. Carbon was in the middle. Carbon belongs to second period. It will follow the octet rule. So this is the correct structure. Nitrogen also follows the octet rule. It is the correct structure. Oxygen also follows the octet rule. It is a correct structure. So till the time the central atom, the central atom is boron, carbon, nitrogen, oxygen, fluorine, which is going to be your second period element. Then though Lewis dot structure is correct. It is correct. They are following the octet rule. They have to follow, because in the second shell, maximum 8 electrons only you can keep. All of you have studied this in your previous classes, that shell 1 we can keep only 2 electrons, shell 2 we can keep maximum 8 electrons, but shell 3 you can keep 18 electrons. Why do you want to follow the octet rule? These people belong to third shell. They have 3 shells. Yes or no? So for third period member, they have no compulsion to follow the octet rule. They have no compulsion to follow the octet rule. So in most of their compounds, they will not follow the octet rule. In the drawbacks, we will write them. Okay. Then we have NO2 positive. Nitrogen will follow the octet rule. So whatever structure you will get will be correct structure only. Let us draw. TVSU. T means how many electrons required? 3 people all say we need octet. 24. Valence. Nitrogen has 5 valence electrons. Oxygen has 6 valence electron. 5 plus 12, 17. But there is a positive charge. So I'll remove that 1 electron out of it. So 1 electron is removed from NO2 to become NO2 plus. So 5 minus 1, 4. 4 plus 12, 16. 24 minus 16. So shared electrons come out to be 8. 8 shared electrons. And unshared electrons come out to be 16 minus 8, which is also going to be 8. Okay, let us draw the structure. Nitrogen in the middle, 2 oxygens on the side, giving them 8 shared electrons. 1, 2, 3, 4, take 1 more bond, 5, 6, take 1 more bond, 7, 8. Nitrogen says, I am so happy, don't give me any more electron. Don't give me any lone pair or anything, I am happy. Okay. Then we'll give unpaired electrons to oxygen only. 8 we have to give. 1, 2, 3, 4, 5, 6, 7, 8. This oxygen is also happy. And this oxygen is also happy. So this is the structure of NO2 positive. N double bond O, double bond O. Okay. And you might ask, sir, where is the positive charge? I told you, you should just remember about oxygen ka, nature. Whenever you give 2 bonds to oxygen, it will not get any charge. Whenever you give 1 bond to oxygen, it will get a minus charge. So here the oxygens are neutral only. So positive charge will be on nitrogen. Positive charge will be on nitrogen. So you will see that nitrogen wants to make 3 bonds. So whenever nitrogen makes 3 bonds, it will not get any charge, like in ammonia. Nitrogen, when it makes 3 bonds, nitrogen does not get a charge. But whenever nitrogen makes 4 bonds, it will get a positive charge. Then one doubt will come into your mind, sir, in NO3 minus also nitrogen has 4 bonds, sir. 1 bond, 2 bond, 3 bond, 4 bonds. Sir, here also nitrogen has 4 bonds, but where is the positive charge? There is positive charge. You can't see it. It is invisible here. Okay, wait for 10 minutes, you'll understand. There is positive charge. You cannot see it, but it is there. We call it as formal charge. Sometimes charges are not visible. But they are there. When is there an invisible charge? Remember it, bache. invisible charge will be present whenever someone has a coordinate bond. This arrow type of bond, coordinate bond. So whenever there is a coordinate bond, there is some invisible charge that you cannot see, but it is there. Okay. We are not studying the whole chapter. I am just trying to tell you how to make structures. Okay, bache. Please understand. My aim is not to teach you chemical bonding right now. Chemical bonding is a chapter which takes 1 month to do. My aim is not to teach you chemical bonding chapter. Everything will be coming in the main classes. Right now, my motive is only that if a molecule is given to you, how do you draw its Lewis dot structure? How do you draw its correct structure using other theories also? Okay. So, can you see a coordinate bond? Yes. Can you see a coordinate bond? Yes. So, whenever there is a coordinate bond beta, whenever there is a coordinate bond like this, always remember the giver from where the arrow is starting will get a positive charge always, and the acceptor where the arrow is going will get a negative charge. Giver always gets a positive charge, taker always gets a negative charge. So there is actually +1 charge invisible on A. There is actually -1 charge invisible on B. These are invisible charges. We'll see how these charges are coming. I'll tell you the formula. Okay, first you remember it. As a trick, you remember it. So as a note point, you can mention. Okay, so wherever you have drawn the coordinate bond, you can just draw those +1 invisible, -1 invisible. In carbonate, there is no invisible charge beta. In carbonate, we drew the structure yesterday. There is no coordinate bond, na? There is no coordinate bond. So carbon has no invisible charge. This oxygen has no invisible charge. Only these two oxygens have -1, which are visible to you. In nitrate, and nitrogen had a coordinate bond. So nitrogen has +1 charge. You cannot see it by your eyes, but it is there. It is experiencing a +1. This oxygen is experiencing a -1. Same way ozone, very important structure. See ozone. This oxygen is experiencing a +1 charge. Okay, this oxygen is experiencing a +1 charge. And this oxygen is experiencing a -1 charge. Means, very important. No matter the charge is visible or not visible, whenever oxygen gets a single bond, it always has -1 charge. Always. Whenever oxygen gets a single bond, it always has -1 charge. It was not visible here, but it is there. It was visible here, it was invisible here, but it is there. A single bond pe oxygen is never happy. Whenever oxygen gets a single bond, it will say, give me minus. If you say that we don't have minus to give, then it will say, give me coordinate bond. Then also I am getting minus. It's just invisible minus. It is as good as minus. Okay. And whenever oxygen is getting a single bond, if you have negative charge to give, you will always give a minus. Okay. So what is the story of oxygen? I told you yesterday also. What is the story of oxygen? Remember it. Remember the story of oxygen and nitrogen. Other elements you will never face problem. Just remember the story of oxygen. Whenever oxygen gets a single bond, it will get a -1 charge. Or that single bond has to be coordinate towards the oxygen. So with single bond, oxygen can be present in two ways. Then in single bond, when the coordinate bond is there, it is experiencing a -1. It is invisible. It is invisible. Okay. Whenever oxygen makes two bonds, either it makes a double bond or it makes two separate bonds, it is neutral. It will not get any charge. Like in the case of water, it was making two different sigma bonds. And in the case of a C double bond O, where the carbonate was there or nitrate was there, it will not get any charge, zero charge, neutral. And whenever oxygen will make three bonds, it will always experience a +1 charge. Oxygen will maximum make three bonds only, not more than three. So this is the story of oxygen. Whenever it makes single bond, whenever it makes one bond, it will experience -1 charge. Whenever it makes two bonds, it will be neutral. whenever it makes 3 bonds, it will always have a positive charge. Okay, see in the ozone, you have drawn the ozone. Look at the central oxygen. In the ozone, central oxygen is making 3 bonds beta. In the ozone, central oxygen is making 3 bonds, 1, 2, 3. It is experiencing a +1. It will always experience a +1. Okay, like in the case of H3O positive also you can draw H3O positive. We can see H3O positive, hydronium we call it, hydronium. Let's draw hydronium. Okay, TVSU. Total. Hydrogen says I follow duplet rule. So 3 hydrogens, duplet, duplet, duplet. 1 oxygen, octet. 6 plus 8, 40. Valence. Hydrogen, 1, 1, 1. So 3. Oxygen, 6. And positive charge means 1 electron is removed. 8. 14 minus 8 shared, 6. 8 minus 6 unshared, 2. Unshared, 2. So what is the structure of hydronium? Oxygen in the middle, 3 hydrogens on the side. Start giving the shared electrons. 6 are there, na? 1, 2, 3, 4, 5, 6. Hydrogen says, I am too happy. Don't need anything else. I am very happy. I am very happy. I am very happy. Correct? Hydrogens too are happy. Oxygen says, I am still not happy. So oxygen will give you unshared electron. You take 2 unshared electron. Now are you happy, oxygen? Oxygen says, yes, now I am happy. I also have 8 electrons with me. Like this. So what does the structure become? It becomes O, single bond H, single bond H, single bond H, and a lone pair. Then you can see that there is a proper positive charge. So where the positive charge will be? It will be on oxygen. Whenever oxygen makes 3 bonds, it always gets a positive charge. This is hydronium. So ozone mein also there is a positive charge on oxygen. In hydronium also there is a positive charge on oxygen. In ozone, the charge was not visible. In hydronium, the charge is visible. So whenever oxygen makes 3 bonds, it gets a plus charge. 3 bond, it gets a plus charge, and it gets 2 lone pair. That also you can remember, 1 lone pair. So whenever oxygen will make 3 bonds, it will have 1 lone pair, means 2 unshared electrons. Whenever it will make 2 bonds, it will have 2 lone pairs. 2 lone pairs. And whenever it will make 1 bond, it will have 3 lone pairs. So oxygen is always keeping its octet complete, means around oxygen there are always 8 electrons. So if 2 in sharing, 6 unshared, 2 in sharing, 6 unshared, 4 in sharing, 4 unshared, 4 in sharing, 4 unshared, 6 in sharing, then 1 unshared. So 3 bonds, you get a plus charge on oxygen. Whenever oxygen makes 3 bonds, it gets a positive charge and has 1 lone pair. Okay, 2 unshared electron is called as a lone. Lone means unshared, pair of electrons. So this is 1 lone pair. Whenever it makes 2 bonds, it gets neutral, means no charge. No charge. And 2 lone pairs. 2 lone pairs. Okay, 1 lone pair, and this is second lone pair. 1 lone pair, this is second lone pair. And whenever it makes 1 bond, it gets a negative charge, minus charge, and it always gets 3 lone pairs. It always gets 3 lone pairs. This is the story of oxygen. Just learn the story of oxygen, because in 99% of the molecules that you do, where you get surrounding atom will be oxygen only. Okay, so don't have to learn the structure, don't have to learn the story of any other element. You'll never require it only. Only in the case of oxygen, you will need it. Okay. One more, let us try for the Lewis dot structure, and then we will be moving forward to other structures. Okay. So this one you can quickly write, and I'll just open the chat for next 2 minutes. I want everybody to tell me that whether it is crystal clear or not. How to draw TVSU, how to draw the structure, and how much charge will be there on the oxygen. Okay, just quickly tell me in the chat box. Can you open? If it is clear to you, just write crystal clear. Good. Good. Hydronium once again. Mahalakshmi beta, you can see here T of hydronium, T total electrons, just T is a fixed number beta. T is total electrons, it's a fixed number. Whenever there are hydrogens, you will take T value as 2. Each hydrogen ke liye T is 2. T means duplet, octet, duplet, octet. Hydrogen says I want a duplet. Other people say I want a octet. 3 hydrogen says we want duplet, 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 6. 1 oxygen says I need octet, 8. 6 plus 8, 14, that's all. Done? Okay, good. Good everybody. One more I want you to try, and you can tell me in the comment box that how many coordinate bonds are there, what is the formal charge, what is the charge on the central atom. Okay, you can all draw for ClO4 negative, draw Lewis dot structure, following octet rule, draw the Lewis dot structure following the octet rule, and tell me how much formal charge on chlorine is present. You will get a wrong structure. Beta, whenever I say Lewis dot structure, I am asking you for the structure according to TVSU. Okay, I am not asking what is the correct structure. Sir, in NO2 positive, there was no coordinate bond. Sir, why was there a plus charge? Beta, nitrogen, whenever it makes 4 bonds, it will experience plus 1. Whenever nitrogen make 4 bonds, it will experience plus 1. Always. This plus is a visible charge, beta. Nitrogen's story is also simple. You can learn the nitrogen story. Story of nitrogen. Whenever nitrogen will make 1 bond, although you will never see it, it will get a -2 charge. Whenever nitrogen will make 2 bonds, it will get a -1 charge. Whenever nitrogen will make 2 bonds, it will get a -1 charge. Whenever nitrogen will make 3 bonds, it will not get any charge, neutral. And whenever nitrogen will make 4 bonds, it will get a +1 charge. Nitrogen making 4 bonds, 1, 2, 3, 4, it will always get a +1 charge. So story of nitrogen is also simple, beta. 1 bond -1 charge. 2 bonds one bond -2 charge. 1 bond means -2 charge. 2 bonds means -1 charge. 3 bonds means no charge, neutral. And 4 bonds means +1. Okay. Every atom has a capability that maximum I can make these many bonds only. If you give me any extra bond, you give me a +1 charge. Like oxygen's maximum capacity was 2, but when you give it 3, oxygen gets a +1. Same way, nitrogen capacity is to take 3 bonds, but when you give it the 4th bond, it will get a +1 charge. Okay. How much formal charge comes on the chlorine? I will draw it. You can stop the chats. Okay. I will draw it, and then I will tell you how to check the formal charge. I will give you formula for formal charge as well. So I will draw that ClO4 minus TVSU. 5 atoms are there. All 5 atoms say that we need octet, 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 octet. 5 people need octet. 5 people requiring 8 electrons, 40. Valence electron. Chlorine belongs to fluorine family, 7 valence electron. Oxygen has 6 valence electron. Negative charge means 1 electron extra is added from the outside. 1 electron extra is added from the outside. So 7 plus 1, 8. 8 plus 24, 32. 40 minus 32, 8. 8 electrons in sharing. 32 minus 8, 24 electrons as unshared. 24 electrons as unshared. What structure are we getting from here? Chlorine, 1 oxygen, 2 oxygen, 3 oxygen, 4 oxygen. 4 oxygens on the side. Sharing electrons, 8. You take 2, you take 2, you take 2, you take 2. Chlorine says, my octet is complete. Do not give me anything else. Okay. So oxygen will get the unshared electron. 24 are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, I am done. 19, 20, I am done. 21, 22, I am done. 23, 24, I am done. All oxygens are happy now. All oxygens are happy now. All oxygens are happy. This oxygen is also happy. So this is the structure of ClO4 minus. Its name is perchlorate. What is the name and all you will learn later, not required right now. This is ClO4 negative. So chlorine, single bond O, single bond O, single bond O, single bond O. Oxygens are single bonded, say give me negative charge, and we are saying that we don't have 4 negative, we have only 1 negative charge. Okay, one of the oxygen you to take -1. Other 3 oxygens you take coordinate bond, you take coordinate bond, you take coordinate bond. Then how to check the invisible charges? I told you formal charges. Whenever there is a coordinate, giver gets a plus, taker gets a minus. Chlorine gets a plus from here, chlorine gets a plus from here, chlorine gets a plus from here. So chlorine will get 3 positive charge here, 3 positive. How did we do it? I just told you na beta. Every coordinate bond A to B, A must get a +1, B must get a -1. So chlorine feels +1, oxygen feels -1. Chlorine feels +1, oxygen feels -1. Chlorine feels +1, oxygen feels -1. Okay. This is how Lewis thought the structure is. This is not what I am saying. This is not what reality is. This is a wrong structure. Okay, it is a wrong structure, but it is the Lewis dot structure following the octet rule. I will correct this structure. Structure will be corrected very easily. Just one thing you have to keep in mind. Just one thing you have to keep in mind, structure will all be corrected. Whenever there is a third period member, whenever there is a third period member, third period, fourth period, fifth period member, like any higher person, chlorine, sulfur, phosphorus, bromine, selenium, iodine, all these people, they will never tend to make a coordinate bond with oxygen. They hate to make coordinate bond with oxygen. They hate it. They hate to make coordinates with oxygen. Why? Because every time they make a coordinate bond, they feel charged. Nobody wants to remain charged. Everybody wants to remain neutral. Okay? Neutral molecules are always more stable as compared to charged molecules. So they never like to make coordinate bond with oxygen. Instead of coordinate bond, they will say, let's make double bond only. Oxygen, you make double bond with me. Oxygen, you make double bond with me. Oxygen, you make double bond with me. All 3 oxygens say, it says, let's make double bond, because when I make coordinate bond with you, I am getting positive charge and I don't like positive charge. Let's not keep any hidden charges. Let's make double bonds. oxygen, when oxygen makes double bond, you know that oxygen is neutral. So now chlorine has no positive charge. These oxygens have no negative charge. But the problem is octet rule is gone now. Octet rule is gone now. There is no octet rule because now chlorine is making how many bonds? 1, 2, 3, 4, 5, 6, 7. Now around chlorine there are 7 bonds. Means there are 14 electrons. So is it stable? Yes, this is the correct structure. This is the correct structure. Okay. So in order to stabilize themselves, if the central atom belongs to period 3, it will never make a coordinate bond with oxygen. Otherwise it will become unstable. So it will always make a double bond with oxygen. Then the structure is correct. This is the correct structure, but Lewis didn't know it. Today we know it. Okay, by the time Lewis has given the structure, he thought octet is the god of all the rules. Octet rule must be followed. Whatever else is there, he had no idea. Okay, but today we are smart enough. We should know that octet rule is not valid today. So what is the correct structure of perchlorate? This is the correct structure. You can draw it also. This is an incorrect structure. This is an incorrect structure. Mention it. Following the octet rule will give you incorrect structure. And disobeying the octet rule disobeys the octet rule. Then you get the correct structure. This one disobeys the octet rule, but it is the correct structure. This one obeys the octet rule, but Lewis was not a correct person. Okay, so after Lewis, we have had more theories. So from the next theories, this structure will be coming. Same way, you can see here, phosphate. This is not the correct structure, beta. Phosphorus is making a coordinate bond with oxygen. So phosphorus is feeling a +1 charge. Oxygen is feeling a -1 charge. They say we are not happy with each other. We are not happy with each other. Phosphorus, do something. Please remove your +1 charge. Please remove my -1 charge. We don't like these invisible charges. Phosphorus says, okay, I don't have a compulsion to keep 8 electrons in the octet. I belong to 3rd period. I have capacity to keep 18 electrons in my valence shell. Let's make a double bond. So this is not the correct structure, but the correct structure is this: P double bond O, single bond O minus, single bond O minus, single bond O minus. Coordinate only make it double. A normal single bond with a negative charge, you can't touch it. It has to be like this. This negative charge you can't remove because phosphate has 3 negative charge. Only invisible charges you will try to remove. This is the correct structure of phosphate. Okay, you can correct the structure of phosphate. Can you see SO3, everybody? SO3. Sulfur says to oxygen, I am not liking this structure because I am giving one coordinate to you, so I am feeling +2 charge. I am not happy. You are feeling -1. You are also feeling -1. I belong to which period? I belong to 3rd period, sulfur says. I can make how much ever double bonds I want. I can keep 18 electrons with me. So do one thing. I will not give you coordinate. I will not give you coordinate. Let's make double bonds so that our structure becomes stable. So correct structure is S double bond O, double bond O, double bond O. Now it is very happy. So octet is not a condition, beta. From now on, if the question comes to draw Lewis dot structure following the octet rule, you use TVSU. Otherwise, TVSU is also a scam. You will not use TVSU. When you use TVSU, you get wrong structures. In nitrogen, though, I have to follow the octet rule. So this is the correct structure. There is no problem in this structure. So 3 structures we have drawn in the class which were wrong structures. One was phosphate, one was SO3, one was perchlorate, ClO4 minus. So these 3 structures we have corrected also. So whenever center person belongs to period 3, period 4, period 5, TVSU will give you a wrong structure. How do you correct it? Wherever there is a coordinate bond to oxygen, just make it a double bond. It will be corrected. Coordinate became double. Correct structure. Coordinate became double bond. Correct structure. Coordinate become double. This is the correct structure. And I can never correct this structure. This oxygen says, the central oxygen says, I am feeling a +1 charge in ozone. Let's try to make double bond. But I can't do anything. I have 8 electrons around me. I belong to second period. I cannot increase my electrons. So I cannot do like sulfur, what sulfur was doing. I cannot do this. I cannot do this. I cannot give you double bond and a lone pair. Otherwise, I'll have 10 electrons around me. If this oxygen tries to do that, central oxygen, it will have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is impossible to do now. So this is a correct structure. So whenever you see a coordinate bond with oxygen, center person must be second period member. This is the correct structure. This coordinate bond, you can't do anything about it. Because we have followed the octet rule, and nitrogen must follow the octet rule. Nitrogen is period 2 element. It must follow the octet rule. If you disobey the octet rule, nitrogen has not that much capacity, is not there to keep more than 8 electrons. I'll open the chat for you. Quickly tell me if it is crystal clear or not, and then you like the video, and then we will meet you in the next class. Quickly, I have opened the chats. You can mention whether it is crystal clear or not. Okay, that's all for today, and I'll wait for your chat. Bye bye. See you all in the next class. NaCl is an ionic compound beta. NaCl will be done when you come here. I am just telling covalent structures, okay, covalent compound structure. NaCl will be done later. Period 2, 3, 4, these are periods in the periodic table. You can look at the periodic table. All of you have seen the periodic table. Period 2 is up to neon. Period 3 is up to argon. Okay, you can check those small elements. Okay, bye bye. Thank you. Yes, it is +3, yes.